that blue-eyed sun. And where have you been, my darling young one? I stumbled down the side of 12 misty mountains.
What's up, everyone? My project I'm sharing today is called my Pedestrian Alert. So it's my attempt at automotive safety technology. I made it because here in the US we have what are called unprotected left turns. So at some intersections, if you want to make a left turn, you have to watch out for a couple things. So the first thing is you have to wait for oncoming traffic because both you and they have the green light. So once traffic passes, then you're free to make a left turn. But then you also have to watch out for people crossing the crosswalk. So you kind of have to think about two things at once. So I wanted to make this to help remind me that there are pedestrians crossing. So my original idea was to have a verbal warning, something that would tell me to watch out for pedestrians. But I didn't really like the options that I found for making this work on Arduino. So I just made things simpler and basically just have some blinking lights as a visual reminder. And I get a lot of inspiration for my Arduino projects from a great YouTube channel called Embedded Systems Design. And so I'll link up the component that I used in the description and show you where I used that in my project. Alright, here's the setup that I have wired up for testing. So the circuit on the bottom is an Arduino Nano, and connected to that is a GPIO interface driver that's going to be driving 12 volts to power up the LEDs that you see. So I have 5 LEDs. Those ones are 2.2 volts each, and so that's a total of 11 volts needed. So I'm going to use a 12 volt automotive system, so just one resistor is needed, so it's pretty easy to wire those up in series. You just need one resistor. And then also on the breadboard you see there is my hall sensor, and so I connected that to a piece of circuit board, and I have everything wired up with Kynar wire wrap wire. Okay, before I write my main code for my project, I'm going to first test my hall sensor and my output device to make sure that they're working. So I can use this little bit of code to do that. So pin 2 is my hall sensor and pin 3 are my LEDs. So with this little loop program, I can make sure that my hall sensor is wired correctly to make my LEDs blink. So I'll demonstrate that with the magnet and show how this little program can test both the hall sensor and the output device and make sure that everything's working correctly before I program my main code. So this is my main program, and it's a loop, not much more complicated than my test program, and those 45 milliseconds and 24 milliseconds, those are my delay times, and so what that will do is set the blink rate for my LEDs. So I set those times because it makes my LEDs flash at a really fast rate and gives kind of a shimmering effect. Here's my block diagram for my circuit. So we basically have the Nano powering the hall sensor, the GPIO interface 12 volt driver powering the 5 LEDs, and the input-output lines going from the Nano to the hall sensor and the Nano to the driver. So here's the circuit diagram showing the Nano and hall sensor and the 12 volt GPIO interface driver circuit, and the LED symbol represents my 5 LEDs. So here's a completed circuit all wired up in the car, and kind of just put here temporarily on the dash. And here's a close-up shot. Now here's my power supply. So I just used my car's utility 12-volt plug and wired Kynar wire and tucked that underneath the seat. Alright, this is how I mounted my hall sensor. So here's my turn signal. And for now, I've just put electrical tape here to secure it nice and tight. And right here are my magnets. So I have a couple of magnets stacked here and then one just to the side of that. So it'll be a north and a south pole right next to each other. And when I put my turn signal down, it'll turn on. When I put it back up, it'll turn off. Okay, so here's my little pedestrian alert project in action. Alright, so if you use a hall sensor in your project, it might be helpful for you to label the poles on your magnet. So an easy way to do that is to grab a compass and point the face of your magnet close up to your compass, and now the north pole of your magnet is going to attract the south side of your compass needle, and the south pole of your magnet is going to attract the north side of your compass needle. So it's as easy as that, and then you can label your magnet so you'll know which side is which. And one last thing before I go, I wanted to just share this website that I found talking about 10 ways to destroy an Arduino. It will show you a list of 10 things not to do to your Arduino. So I think it's worth checking out, and I'll put a link to that website in the description box. Alright, so I hope you enjoyed checking out the little device that I made.
I've walked and I've crawled on 6 crooked highways. I've been 10,000 miles in the mouth of a graveyard. It's a high, and it's a high.